Now I request Dr. Savita Dubey ma'am to felicitate Dr. A. Vahid Deshmukh sir with the planter.
For the first presentation, I call upon Ms. Shayesta Shabnam.
Good afternoon to one and all present here. Today I, Shasta Shabnam from BTech Chemical Engineering, final year student from MIT's Gwalior is present here to present my paper on valorization of orange peel waste through reactive distillation for sustainable biodiesel production. As this topic looks heavy due to the two terminologies, that is the reactive distillation and the second one is biodiesel. So reactive distillation is a part of process intensification in which two or more technologies are combined together to form a single one. It optimizes at the less cost and it requires less space, and it also increases the productivity and efficiency. The second one is biodiesel. So as we all know, the current scenario of world today that fuels are degrading day by day and the whole world is looking for the renewable resources for the fuel generation. So moving ahead, and let us look at the overview that what I am going to present in this paper. So firstly, I am going to deal with the orange peels. So orange peels are generated in a large amount which are dumped and degraded into landfills. And these are not used in general form, but at cosmetic industries and women's at commercial home levels uses this orange peel, but not in a bulk amount. According to the report of FAO 2021, the annual production of 76 million metric tons of this waste is generated, and we are going to utilize this waste to produce a powerful biodiesel. With the help of extraction technology, we are going to extract the oil of orange peel. Then we will further transfer this orange extracted oil into the reactor distillation for the further procedures. With the help of amphoteric catalyst, we are going to separate this oil to form the product such as glycerol and biodiesel. So let me clarify my objective once again. At starting, we are going to see the experimental analysis. The second one is simulation. The third one is validation, and the last one is optimization. So the chemistry behind this production of biodiesel is transesterification, in which triglyceride, which is present in the oil of orange, is going to react with alcohol. Here we have chosen methanol as an alcohol. In the presence of amphoteric catalyst, it gives the product of glycerol and biodiesel. So ultimately, we are not getting any waste. So moving ahead, here is the schematic diagram. Here we can see that the normal distillation column is transferred into the reactor distillation column by incorporating this middle reactive zone. In this middle reactive zone is placed between the rectifying and stripping section. In this section, we are going to introduce the heterogeneous catalyst such as amber light. This amber light catalyst is amphoteric in nature. We have chosen amphoteric catalyst because suppose our product demands for the acidic or the basic catalyst, then in both the cases amphoteric catalyst can easily work. But here we have to produce the biodiesel with the process of transesterification, and it demands for the basic catalyst such as NaOH. But here we have chosen the solid heterogeneous catalyst, that is the amberlist. So the lifespan of amberlist is very good, and it doesn't require any regeneration over many years. In India, the proper setup of this distillation, reactor distillation, is not industrialized yet. But in 1956, by the Eastman Company, they have introduced this reactor distillation setup and produced the ester with the help of it. This is the research area where we have to work a lot. In India, IIT Bombay and BITS Pilani have the proper pilot scale setup of this reactor distillation, and the third one is our MIT's Gwalior. It also have a proper setup of this reactor distillation. So here in this schematic diagram, we can see that the old methodology of production of biodiesel. Here we required here in this old methodology, we required more space as compared to the reactor distillation. Here we required a reactor. In this reactor, we have performed the reaction. We have to perform the reaction, then it further feed it into the distillation column. Basically, distillation column is used for the separation of products on the basis of volatility. So, in the reactive distillation, we have minimized the space, and its productivity and efficiency increases. Moving ahead to our first step, that is the extraction of orange oil. So, in this, firstly we have taken the orange peel, then we have sun-dried it, and we have made the fine powder of it. With the help of pestle and mortar, we have grind this into the powdered form. We haven't used any electrical grinder, because by using it, we can easily lose all the essential elements from it. So, with the help of Soxylate apparatus, we have extracted the orange peel oil. Firstly, we have put this orange powder into the Soxylate apparatus, and it requires only a single chemical, that is the petroleum ether. With the help of it, we have extracted our oil, and the rest of the data are shown in the slide. We have done this in a large scale. Moving ahead to our second step, that is the reactive distillation and the separation. So this figure indicates the proper setup of reactive distillation. In this distillation column consists of 10 plates, and we have taken mass reboiler duty at 3 kilowatt, and initially the reboiler is filled with more volatile component to attain the temperature within the column. Sensors are attached at each of the sections to record the sectional temperature. We have noted this temperature in our data logger. As soon as the temperature is attained, a feed of lesser volatile component, that is the tert amyl alcohol, is started at the top of reactive zone, so that the upcoming vapors of the ethanol will react with downflowing. From the bottom of this column, we have received the glycerol, we have received the biodiesel, and from the top of the reactive distillation, we have received the glycerol, because glycerol is more volatile as compared to the biodiesel. Therefore, we have received it from the top of our column. So, moving towards our third step, that is the simulation. So, we have done the simulation in the DWSim, and this is the free software which was launched by the IIT Bombay. In this, we have taken the feed inlet flow rate, and we have taken the temperature, pressure, and the other components in it, and we have also used the NRTL property method in it. Here are the results and the analysis. Here we can see that we have achieved the 99% purity of biodiesel, which is a good thing. At the bottom of the column, we can see that temperature is at peak, that is the highest temperature at the bottom of a column, that is the reboiler phase. As we go up in the column, we can see the temperature is decreasing due to the endothermic reaction in which heat energy is consumed. Therefore, the temperature is decreasing, but somehow it increases up to some extent, but not in a great manner. Here is the graph of dynamic simulation. We have used dynamic mode because we always have constant over the limits. For every graph, we need the lower limit and the higher limit. Here, the lower limit is 0.432 and the higher limit as 0.437. This graph represents the dynamic simulation to maintain product purity with reboiler duty as variable. And this graph represents the dynamic simulation to maintain product purity with methanol flow rate as a variable. So as we achieve the biodiesel, now we have to blend it. We can't use it in raw form because the octane number which is required by the CI or SI engine is quite different from the octane number that we have achieved in our biodiesel. So we have to do B20 blending. Basically, in B20 blending, we have to take 80% of the biodiesel along with the 20% of diesel, and these are the data which we can see in this table. Moving ahead, application of products of RD. For biodiesel, The conversion to energy and the secondary conversion is good, but its end use cost is high. For glycerol, the conversion to energy, secondary conversion and end use cost, all three are good. For waste cake, which is the leftover orange peel, its conversion to energy, secondary conversion and end use cost, all three are good. Now I would like to conclude my presentation. So the benefits of process intensification. So as I have told that reactor distillation is a part of process intensification. So its uses in business, process and environment, all three are good. Thank you.
So is it your experimental study?
No sir.
Have you carried out this study?
Yes sir.
On this study you have carried out?
Yes sir.
Okay. So what you are doing, you are just extracting the oil from
Orange peel.
and rather than doing the reaction separately and after feeding them to the distillation column, you are directly using the reactive distillation.
Yes sir.
Okay. Have you heard about the extractive distillation?
Extract. Here we have used the oxalate apparatus for the.
That's fine. So why not the extraction should be also carried out in the same column?
So the extraction of oil.
Yeah.
So it can't be done in that. It basically uses for the extraction of oil.
Have you heard about the extractive distillation?
No sir.
Fine. Okay, my question is actually what you are going to do with the glycerol?
So glycerol is used in many industries in many forms. Like I don't have much idea about this, but I have heard that glycerol is used in many industries for.
You should, okay.
Yeah.
You heard about it, then it's fine. Okay, and how much amount of the oil you are collecting? Means what is the ratio of extraction? Means if
1:4.
No. If you, how much amount of orange peels is should require to get that much amount of the oil?
So here we have taken the 10 grams of dried orange peel powdered along with 100 gram of petroleum ether. Then we have extracted
Okay,
it.
you need again solvent also to extract it.
Yes,
okay.
sir.
And how much amount of oil you get?
So the we have get approx 80 ml, I guess.
Did you calculate the material cost?
No, sir, I haven't calculated that.
See, because if you are proposing some sort of solution, then we should also taste it for the economical viability, isn't it? So it might be possible that the cost of the biodiesel you have produced may be high than the conventional diesel, so nobody is going to use it. And
Yes,
further,
sir.
there is a production of glycerol and much energy is required. The downstream processing cost is too much, so you should do that analysis, all these things there. Okay. And can you just show me your last slide where you have shows that analysis of your biodiesel? So analysis where you have done this?
So which kind of analysis like?
आपने एक टेबल दिखाया ना उसमें last
This
में?
one?
Comparative table इसके पहले.
This
this
one.
So where did you carry it over?
So flash point and fire point we have calculated from Penske Martinskin and
At your institute.
yes sir.
Okay.
And the calorific value we have calculated from bomb calorimeter.
I just want to ask, all of these are authenticated data.
Yes, sir.
All these data is authenticated. Now,
This oxygen
how much
content
cost
we
is
have.
required to prepare 1 liter of biodiesel?
So
That is the first question.
so approx ऑरेंज विद आई मीन ऑरेंज फील के लिए हमने मतलब कोई भी पैसे खर्च नहीं किए थे एंड
So do all this sort of data analysis and just check that this much amount is required to prepare the biodiesel, and it should be too much. It should be too much less than the diesel. Then we can use it, isn't it?
यस सर
Okay, fine.
थैंक यू सर
So can I ask one question?
Yes, sure.
So how do you analyze this oxygen content of biodiesel?
we have taken this oxygen content from literature reviews. Yes, sir.
And how do you analyze this flash point?
Sir, from Penske Martin's apparatus.
For our next presentation, I call Ms. Arya Goyal for her presentation.
I am Arya Goyal, a final year student from MITS Gwalior. Now I am here to present my paper entitled Validation of Experimental Results of Shell and Tube Heat Exchanger using the simulation software. So basically the motivation of my study is, as we know, the simulation, it refers to imitate the real world identities into the software form. So it saves the cost, the time for the execution of the experiment. And in this research, we have shown the simulation of the heat transfer processes, which is a very common process in all the chemical process industries. So the motivation is from the MIT's heat transfer lab, where we have faced many problems such as the cost of the execution, the time of the execution, the scaling of the equipment, and many more. So the case which we have taken here is the case study which we have further continued is for the shell and tube heat exchanger. So let's introduce the simulation. Basically, the simulation, it creates a prototype of a physical model into the software form. So we can predict the performance of a physical model on the software only, how it will perform in the real world. So I have performed the simulation in the DWSim, which is the free simulation software developed by the FOSI and IIT Bombay. Let's discuss about the heat exchanger. It is an equipment that efficiently transfers heat from one medium to another, and it has a low maintenance cost. So, and it was also available in the institute. So let's discuss the methodology for my experiment which I have worked on. Firstly, we should let's see, this is the image of the shell and tube heat exchanger which is present in the institute. So firstly, we should clean the equipment and remove all the dust present in the equipment. Then we should close all the available drains in that, and check all the on-off switches on the panel should be in the off position, and we should fill the water bath up to the 3/4 of its capacity. Then we should switch on the main power supply. Then we should turn on the heater with the help of a rotating switch present on the panel. Then there is a digital thermometer connected with it, from where we can adjust the temperature. Then the flow control valves and the bypass should be kept open for the hot fluid supply. And when we get a steady state, we should note all the temperature, inlet and outlet temperatures for our further process. So now let's proceed with the simulation, and I'll explain the simulation which I have worked on. So firstly, we should open the process simulator, and in the process simulator a wizard window will appear, on which we have to choose the compounds which I have used as methanol and water. Then we should introduce a material stream which should be named as methanol in, and all the desired value should be mentioned in that. And another material stream should be introduced, and it should be named as water in, and all the desired values should be mentioned in that too. Two more material streams should be introduced and further named as methanol out and water out, and all the 4 material streams should be connected with each other. And now we should move further. We have used the Raoult's law as our property package, because a property package should also have to choose in that. So, and similarly, all the desired data is mentioned at the places. So at last, we should navigate to the calculation parameters, and we should select the shell and tube heat exchanger ratings. Then if the flow sheet is ready and all the values we have got, then we should proceed further with the solutions and click on the solve and get our results. So these are the images. The first image is for when we have selected that compounds, and the second image, last image was when we have added all the material streams with the shell and tube heat exchanger. And the second image is we should select this all of these columns for what the values we need. Now coming to the results, we have shown the variations of temperature profile when we have kept the inlet temperature constant. So as you can see, there are 2 tables, one for the simulation and one for the experiment. The inlet temperatures for water and methanol is kept constant in both, but we can see the outlet temperature for water and for methanol varies from each other a bit. So these are the graphs of temperature profile obtained at the constant inlet temperatures as shown in the below. Water flow rate versus water temperature graphs, these are. So the first one is the simulation graph and second one is the experimental graph. Here we can see it deviates from each other a bit because of as we know, there is a human error always when we perform any experiment. So these 2 are the graphs for the methanol flow rate versus outlet methanol temperature. So first graph is for the simulation and second is for the experiment. There is a lot deviation, a more deviation we saw. So This is the variation of temperature profile when we kept the flow rates constant. So here we can see we have kept the water and methanol's flow rate constant here, and we have given the inlet temperature and got some temperature for water and methanol, outlet temperature for these both, and it deviates from each other. So similarly, these are the graphs for the outlet water temperature versus inlet water temperature. So here also we can see the deviations in the simulation and the experimental graphs. So these are the graphs for outlet methanol temperature versus inlet methanol temperature. These are the, similarly we can see the deviations here too. So we'll get these deviations every time we perform an experiment and a simulation. This is the data of various parameters obtained in the simulation when we kept the flow rate of 650 kg per hour and 800 kg per hour of water and methanol respectively. So these are all the values which we have obtained from the simulation only. Now I want to conclude the presentation with the result shows that the flow rate of 1000 kg per hour each, we get the outlet temperature of 66.10 degrees Celsius and 27.68 degrees Celsius of water and methanol respectively. The pinch analysis shows that the cold utility of approximately 2 watt while the hot utility was 1.5 watts. Simulation studies are rigorous in nature. It saves time, cost for a live experiment, and thus it can be said to be a technological reform. I also want to add, as we are now here focusing on the sustainability, so I think this is a sustainable option for experimenting, because if we can perform the simulation even from the home or from any place if a person do not have these apparatus and all, and it saves the time, it saves the cost, and it also reduces the pollution because we don't have to physically perform the experiments every time. So and also there is no waste product.
So you have the parameters of the heat exchanger.
Yes.
So you perform your experiment in your lab.
Yes, I have performed the experiment in the lab as well as in the simulation software.
So how many number of tubes in your shell and tube exchanger?
There is one shell and many number of tubes are present in there.
Because you written there is 1024 number of tubes there, and the tube length is 5 meters. So it's I think an industrial scale apparatus, not a lab scale.
Where, sir? Where I have written
All
that.
the slides. Yeah. So the tube length is 5 meter, and 5 meter is a too large.
In this table, no. Actually, this is for the this is from the simulator. This is from the simulator which we have obtained from the DWSM.
How do you compare with the 5 meter to your lab scale? Because you did in a simulation and you perform in lab scale. So you should take the parameter as per the lab scale equipment designing. Because lab scale equipment design somehow it's 80 centimeter length
Yes,
of the tubes. So you should take that. Then we have to compare. So it's two different tasks. So you cannot get the
Same results. Yes.
And one more thing is, you took the flow rate, how much flow rate you took for the methanol in water?
1000 kg per hour for the water and outlet temperatures हैं 1000 kg per hour.
Go to the second slide. Next. Here you took the mass flow rate is 15,000 kg per hour. It's two different, 15,000 and 25,000.
Actually, sir, this table, this is not the table related. Yes, it is like an example we can use only.
It is an example, and you took the
1000 kg per hour. Yes.
So it is possible in lab scale.
That was also from the simulation only.
That's my question. How you correlated?
Yes, sir. I understand your question.
You can look this one.
Yes, sir. I'll work on it definitely.
Okay. First you have done the experimentation,
Yes, sir.
and after that
Simulation.
simulation. Then you compare both.
Yes.
Why you are not perform the statistical analysis? Means in terms of difference between the experimental value and difference between the
Simulation
simulation
value.
value. You know the
Yes,
statistical parameter?
Yes.
Chi-square value, RMS,
हाँ
then regression coefficient, all this. So that will directly explain you that how your simulation is proper. or
कितना
not.
deviation changes. Okay, yes sir.
And during the experimentation, you have maintained the inlet temperature of the water at 10 degrees centigrade. How is this possible? Means in lab basis, huh? You shown in lab basis. Your inlet temperature.
अच्छा एक सेकेंड. Inlet temperature 10 degrees Celsius.
No,
This is the
let us see. Water in at 10 degrees centigrade. You are done in the lab.
Lab scales, yes.
So what was the inlet temperature? 10 degrees centigrade.
Yes, because a thermometer, there is a digital
So how you
thermometer.
maintain the temperature at 10 degrees centigrade? That I got.
you have to circulate the cooling water.
हाँ.
You have
Sub-
circulated it.
Supply of cooling water,
You have
yes.
supplied it. Means before feeding the water, that water was maintained at 10 degrees centigrade absolutely. For that purpose, what you have done, you have taken.
Maybe there may be human error or plus
No,
0.5
what is
minus.
the room temperature in your lab? Maybe 30 degrees or something like that. So,
Then you have to reduce the temperature.
हाँ,
inlet temperature.
yes.
How
so why you have taken only 10 degrees? Means you can work
Yes,
on the
we can, yes,
room
normal room temperature
Why to waste
also.
energy to reduce the temperature to the 10 degrees?
Yes, sir, yes.
Again, the cost will be
Increased,
And-
yes.
And then the next thing is that your methanol you have feed, you have
Huh.
chosen the hot liquid methanol.
Methanol.
Why methanol? Methanol is very costly and not easily available.
Yes,
You can use the hot water.
yes, yes, yes.
And how you maintain the methanol temperature 80 degree? I think the boiling point of methanol is
close to 68, 69. 68, 69.
are you getting me?
Yes, sir, I am.
Then it will start.
Have you really performed the lab study?
Yes, definitely.
Then first upon taking a vast amount of methanol, maybe
I
your
understand.
lab instructor will not be happy to issue you such amount of methanol.
How much ethanol you have to?
Instead of taking a hot fluid, you can take as a cold fluid.
No.
Actually, sir, I was not even aware of all these ways.
Your lab instructor allow you to use the methanol.
Yes.
How much quantity?
How much quantity you have used? Because your heat exchanger is, I think, on a medium
What
scale.
is the capacity of it? Volume of it?
Maybe she has a doubt. Maybe sir, water is a hot fluid or methanol may be a cold fluid. I thought.
That's why, but on UG level, it is very good
Yeah,
study.
good.
Yes, that is the
I appreciate your work.
But you keep some points
Yes, sir.
in your mind.
Now I call Mr. Raj Singh Baghel for his presentation.
So good afternoon to all and everyone present over here. I am Rajendra Baghel, a student of final year Chemical Engineering Department, my MITS Gwalior. Is presented over in ETDSE 2024 to present my paper on bioenergy, a sustainable energy option for Madhya Pradesh. So we should get an idea about what bioenergy is. So let us discuss. So before going for that, let us know the question may arise why this topic only. As we all know, all over the world, the fossil fuels are degrading day by day, and as the renewable energy target of India, we have to make a CO2 emission to become net zero, and the carbon emission should become net zero by 2070. And we are aimed to produce 500 gigawatt from renewable energy by 2030, which is soon to come, and 100 gigawatt from solar energy by 2022. So, as we know, India is working in a vast level on solar energy, and I am presenting it on incoming slides. So now, what bioenergy is? The energy which is generated from organic matter, and the organic matter is is a compound which constitute a major quantity of carbon and hydrogen in it. Now, as per the state-wise scenario, we can see collected by National Biomass Resource Atlas, updated in 2023 by IISc Bangalore. We can see Madhya Pradesh and Maharashtra are at the highest peak of agriculture residue and forestry wasteland, followed by Uttar Pradesh and Rajasthan. So in Madhya Pradesh, we have the good agriculture residues and forestry land which we can use use to convert it for bioenergy. We are at the second position in agriculture residue, and share equal position, that is the first position in forestry wasteland. So Madhya Pradesh has a very good potential to work on renewable energy. As per Indian power sector, the renewable energy which we are utilizing is 22.4%. In hydro, we have 12.6%. In nuclear, very less, 1.9%. And gas-based, we have 6.9%. But we are very much dependent on coal, that is of 56.2%. Now coming to Madhya Pradesh Sustainable Development Goal Target, there are 17 Sustainable Development Goal Target, and Madhya Pradesh is highly working on goal number 7, which is affordable and clean energy. And the world's largest floating solar energy project of 600 megawatt is to be constructed at Omkareshwar at the site of Narmada River in Khandwa district of Madhya Pradesh. So we are having the potential of becoming the world's largest potential of exploring the available renewable energy. So the initiatives till now taken by the state government to boost biomass energy production are like in Katni Mundwara, we have the first biomass energy generation project. In Jadukheta at Dhar district rice husk based gasification plant is set up of a capacity 0.59 megawatt. In Indore and Balaghat districts, again we have a rice husk based biomass plant, and naphtha based gas power plant is in operation in Gwalior, which also my study town. And at Katma and Khargon, a power generation plant is set up which operates from the waste material of the city. So we are having very much potential to explore the available renewable energy. So now the question may arise, if we have that much the potential, that what are the techniques by which we can convert the waste biomass into useful energy? Like we cannot say a villager or a farmer that आपके पास ये wasteland or forestry है, I convert this into energy. We have to be technically sound, and then here the chemical energy in engineering comes into play. We have studied many techniques, various techniques like pyrolysis, gasification, torrefication, liquefaction to explore the available renewable energy. So my focus is basically on pyrolysis. So what pyrolysis is? It is derived from the two words pyro, which means heat or fire, and lysis, which means separation. That is we use only heat to produce useful energy from the waste. Now the waste which we are using is plastic waste. There are many kind of plastics like polyethylene, terephthalate, HDP, LDP, and many more. And every type of plastic has a trademark assigned for their origin or a type. Now why the question arises, why the plastic only? Because it is a huge concern in Madhya Pradesh, not only in Madhya Pradesh but also in India. As Indore has the first rank as the cleanest city in India, but the other cities is lacking behind to get that position. So I am studying in Gwalior, and I personally feel that the Gwalior is whole surrounded by the dumped landfills, which are basically consisting of the plastic waste. So from here it comes into my mind to take it as my project in my graduate degree. So the question may arise, how pyrolysis can be a solution? So the pyrolysis, it can be a solution for managing plastic waste effectively as it involves the thermal decomposition of organic materials in the absence of oxygen. The main concern here is the absence of oxygen. That is, we required an nitrogen inert area for performing this activity. For pyrolysis, firstly we have prepared the feed, that is, we used low density polyethylene as a feed, and a catalyst, activated charcoal, and the apparatus required here are nitrogen cylinder, coil heater, tubes, pipes, metal containers, separating funnels, and all the containers and the tubes I have collected from the warehouses where it is dumped and are of no use. So basically it is from the waste. The charcoal is used 1/4 of the feed. Now the steps involved in this process is, firstly we collected the plastic. No sir, it is activated charcoal हमारे लैब में ही था, तो सर हमने एज अ बायोमास प्रोडक्ट इसको यूज़ किया है सर, एज अ कैटलिस्ट ही ना बात सर, बायोमास की तरह हमने इसको यूज़ किया है चारकोल को, एक्टिवेटेड चारकोल को एज अ कैटलिस्ट.
नहीं वो चारकोल का अच्छा यूज किया.
हाँ, यूज किया हुआ है. सो एज अ कैटलिस्ट वो यूज है. So the steps involved in, firstly we collect the plastic, sorted it and cleaned and set it into small pieces. In heating phase we introduced it into a high temperature reactor about 300 degrees without oxygen, and thermal decomposition where polymers break into smaller molecules, then volatile molecules create a vapor phase and continuously cooled to condensate volatile components, and oil is to be separated. This is the very prototype of pyrolysis which we have made and worked upon, where the yellow orange container is our feed tank and the other one is the collecting container. To make it to make it oxygen free, we flush the nitrogen from the nitrogen gas from the valve. Now for the results, we have the characteristics of the liquid. Here I have taken the ratio of LDP and SDP of varying feedstock. As the percentage of SDP is increasing, the yield of pyrolysis oil.
These are your results?
Yes, sir.
Your experimental study results?
Yes, sir.
Then why didn't you type it but you have taken the snapshot there?
Sir?
रिजल्ट का स्नैपशॉट क्यों लगाया वहाँ पे? आप टेबल में भी तो टाइप कर सकते थे या कहीं से उसको क्रॉप कर?
No, actually ये सर ये कैनवा में बनाया हुआ है, तो सर हमने इसको वहाँ पे पेश करने टू यूज द presentation के लिए. So at last I would like to conclude that Madhya Pradesh has a good potential of about 58% of the energy generated in the state is from thermal sources and 42% from renewable energy. Waste biomass is the potential to produce renewable fuels and fine chemicals. I know the question may arise in your mind that I am focusing on biomaterial, but my case study I have taken is as the polythene. So why I am correlating this? Because as I mentioned, I used activated charcoal as a catalyst, which is in the bio form because the main component in the is carbon and it does not contain any other chemicals. Secondly, in the context of bioenergy, the liquid fraction obtained from plastic pyrolysis, often related to as a pyrolysis or a bio-oil, which can be utilized as a potential source of bioenergy. The bio-oil can be further processed and refined to generate heat, electricity or biofuels. So the connection lies in the transformation of plastic waste through pyrolysis, leading to the production of bioenergy in the form of bio-oil. So this is how I related my study from bio to plastic to fuel, that is energy. Thank you. Thank you everyone. Thank you so much. Sir.
What kind of plastic you have used? LDP?
Yes, sir, LDP.
So what are the raw materials? How you choose the LDP?
Sir, my raw material is LDP only.
How you choose the LDP? Means there are a different mixture of plastics. So
Yes,
how
sir.
you segregate the LDP from that?
So basically it the LDP is a plastic bags and all the sort of. Yes, sir.
So you are
From
using the carry bag.
yes, sir.
So you are taking the temperature range is 300.
300. Sir, actually it is the overall temperature because as we know, pyrolysis has a different category: fast pyrolysis, intermediate pyrolysis, and flash pyrolysis. So it is for the basic temperature. So the temperature which we have maintained is about 1300 to 350 degrees Celsius.
1900 to 300.
350.
So you wrote there 300 to 800 now.
Yes, sir. Yes, sir. Okay.
So you should write 300 to 350.
Okay, sir.
Slow pyrolysis.
Okay.
So the LDP is degraded at 350.
Yes, sir. It will.
Because LDP, the maximum degradation temperature is around 420, 430.
No, sir. Sir, actually we have the coil heater and it mainly have that maintain. Yes, sir.
And how you made this your activated charcoal?
Activated charcoal, sir, we have in lab. So we didn't made it actually. We used it as a. Yes, sir.
So it's marketed activated
Market
charcoal,
activated charcoal.
not from the biomass.
Yes, sir.
So your thought is to make this type of.
Yes, sir.
Okay, I have one question actually.
Sir.
Actually, you yourself are asking a question in our mind.
Yes, sir. Okay. No, actually I thought we use plastic.
My question is,
Yes, sir.
your title is bioenergy,
Yes, sir. Bioenergy.
and you are just converting the plastic into the oil.
Oil.
So, and then a sustainable energy option means we have not created any sort of energy. We are converting the plastic into the oil.
Yes, sir. Oil.
Okay?
Yes, sir.
Means you are even the plastic is not also biomass.
Yes, sir. So it is not a biomass. Actually, as I explained, the biomass which I used is activated charcoal.
Just I read your title. If I read your title and not your presentation.
Yes, sir.
What I am going to presume that there is some sort of energy created
Yes, sir,
from
sir.
bioenergy. So just change your title.
Okay, sir. Okay. Very well.
Because you should be very aligned.
Yes, sir.
the
Yes, sir.
title.
Yes, sir.
And
Yes, sir.
the next thing is that you only worried for Madhya Pradesh.
So no, actually it is a sustainable energy option for no, actually it is a case study for the Madhya Pradesh. So that's yes.
Sustainable option for all
No,
Indian
yes, sir.
world के लिए.
Okay, sir. Yes, sir.
Okay,
Very well.
that was mine.
Thank you, sir.
Starting from
Now, I would like to call upon Dr. Saurabh Singh Raghuvanshi sir for his presentation.
So first of all, very good evening to all. Myself, Dr. Saurabh Singh Raghuvanshi, or I am working as an assistant professor from MITS Gwalior. So this is my research topic, and why I choose this research. Actually, we all are know the water is very valuable for all over the world. So why choose in our area, that is the Gwalior Bard zone. So in our area, that is the lot of pond, step wells and wells is there, but due to the continuous development of here that place, so after the continuous development they are not working currently. So I choose that they are the one of the diffusion of water losses in the particular extent bodies. So I choose this कि if we are working for already they are available in the resources, we are regenerate of resources and we are using for further like for a drinking purpose or maybe saniting purpose. So we are choosing that in particular in our place. But actually in all over India there are a lot of ancient time or they are already lot of step wells is available, ponds is available and water sources available. But due to the development of continuously they are the resources is depletion. So let's discuss in our next. So this is the agenda regarding to this, the introduction, and the second is history, methodology, sample analysis, result, discuss and future work. So if we discuss the first is history, over the time many of the historic Gwalior wells fell into disrepairs and were at a risk of being lost due to neglect. Urban development and changing water management practice, even the ones which are functionally sound are facing water losses due to evaporation and other factors. This is due to higher rate of diffusion which causes decrease in water level of water resources causing drought. So everyone knows the things, what is essential. So we are working in that particular place. There are a lot of step wells is available in our Gwalior region. So the one of the researchers, that is the Brown and Craig in 1998 and 2005 had says that the amount of stored water lost to evaporation depends on many factors, like including atmospheric evaporation, demands, size of reservoir and storage method. The second researcher in the 2010 as Azoline, that is says evaporation losses can be reduced by altering storage design from increasing reservoir depth to installing windbreak or covering reservoir surfaces. And our third researcher, that is the K. Narkis, DOR 2010, had says evaporative losses from large water bodies may exceed 20% of water used in irrigated agriculture, with losses from reservoir esteemed at 50% of storage capacity. So this is our background for our research. Now the type of diffusion, there are the two type of general diffusion. So we are working, actually this is a interdisciplinary research, and architect or civil work is there, and chemical, as a chemical engineer the diffusion portion is there. So in the diffusion there are the two phase, that is passive diffusion and facilitated diffusion. In the passive diffusion it is also known as simple diffusion. Passive diffusion is a process in which the movement of molecules along their concentration gradient without the direct involvement of any other molecules. It can involve either the spreading of material through a medium or the transport of particle across a membrane. Simple diffusion is relevant in chemical reaction, like in most biological system, diffusion occurs across a semi-permeable membrane made of a lipid bilayers. The membrane has pores and opening to allow to passage of specific molecules. This is the basic detail of passive diffusion, what actually this So now the facilitated diffusion. The facilitated diffusion requires the presence of another molecule, like the facilitator is ordered for diffusion to occur. Facilitated diffusion is necessary for movement of large or polar molecule across the hydrophobic lipid bilayers. Facilitated diffusion is necessary for the biochemical process of every cell, since there is a communication between various subcellular organelles. As an example, while gases and small molecules like methane or water can diffuse freely across the plasma membrane, larger charged molecules like carbohydrate or nucleic acid need the help of transmembrane proteins forming pores or channels. So in our, this is the actually mapping of there in the Gwalior ward zone. So this is the identification and mapping location map of water bodies in ward number 1. That is the data is come from the Municipal Corporation Nagar Nigam Gwalior, and this is the blue dot is there. That is the step bells is there in this particular places. So this is the blue dot is in the picture. So this is the water bodies is there, and this is the ward boundaries. So this is the mapping of there, and this is the calculation how to calculate to diffusivity, how to rate of diffusion analysis from in the pilot scale in the lab. So understanding how much diffusion of there in the extent bodies. So this is the formula and mechanically in the behind the research. And now this is the water losses analysis for identical water bodies in ward number. So this is comes from, so in our places there is a lot of areas there, that is the blue dot. So in the one of the places, that is Bodapur is there. So that is the maximum water sources is available. So we are this is the 69.35%. This is calculating by the height and by the diameter of that particular, so how much is available to understand the things for the resources. And this is the result and conclusion regarding to the rate of diffusion versus time. So if the time in the ancient time, the stable is working in the ancient time, so now in the current they are not used, or in the nearest people we are depending on nearest dam or other sources, so we are not handle in our own sources of like in our well or in other places. So that is at the time, that is the water will be diffuses. Also, then the pi analysis, we understanding there is the sum of the color. So less danger, that is the 30% is there, and threatened, that is the 37% is there. So that is the, if we are not maintain that that wells or step wells, so it will be destroyed in the completely. So if we are understanding, or we are trying to again reconstruct or rehabilitate to that water sources, so it will be very useful for near, if the people says living in particular places for the drinking or other purposes. So unthreatened is the 7% is there, and endangered is 26%. So there is the pi analysis. So also the factors that affect diffusion is in the temperature and the area of interaction. In the temperature, with increase the temperature, the kinetic energy of all particles in the system increases the rate at which solute and solvent molecules. Area of interactions, like if the block of dry ice is broken into multiple pieces, the area that interact with the atmosphere immediately increasing, the number of molecules that only collide and other carbon dioxide particles within a dry ice decreases. Therefore, the rate of diffusion of the gas into the air into this is the general described to the temperature and area of interaction. And the rate of diffusion versus temperature means if the temperature will increase, because in our Gwalior region there is the 8 to 9 months is always the summer type of season is there. Due to this, the continuous area is the temperature is high in that particular place. So also there is no time to time rain is there. So that is the, if the temperature increasing, to the water already is available in this particular well or step wells, the water will be diffused from in continuous manner by the time. And this is the rate of diffusion by the depth. If the well depth is too much high, so it will be maybe the water will be not diffused much more. But if the height is very less, so the water is diffused due to the contact of air or the temperature. So it will be so one of the factor is there due to the depth again. And the rate of diffusion of water to dry air versus diameter. So that is the one of the place. If the diameter is more in this particular well, so already contact, a lot of contact is there, interaction with air and water and temperature. It will be remove the water from in the air by the evaporation. And the other application of this analysis in the diffusion, so that will be biological. In the biological sector, study of diffusion in respiration can help to develop artificial respiratory apart from this this water. And then pollution control also, we are using back filter designing, smoke diffusion analysis, and third one, the chemical process industry that has helped dealing with volatile solvent can model vapor liquid explosion and related hazard. So this is the other application of use of this analysis. So now we conclude of our work. Like due to the drought, India faces lot of problem for drinking and irrigation. due to which people suffer from lot of problems. To overcome these problems, we have taken case study of diffusion of water. Varied typologies of water harvesting structure, including well, step wells, tanks, etc., out of which wells of ward one have been considered for the study. These wells are constructed using locally available materials such as stone and bricks, showcasing the craftsmanship and engineering prowess of these times. They serve the purpose like irrigation, domestic uses, culture and religious usage for drinking water, and sources to be developed sustainability. It is crucial to comprehend their flux, diffusion, and environmental risk. The rate of diffusion for which we had ramped their parameters like temperature, diameter, and depth result, so that on increasing the temperature and diameter of the bucket, the rate of diffusion increasing with the case of the depth. On increasing the depth of the bucket, the rate of diffusion decreases. So we conclude that the problem can minimize by covering the wells, which will decrease the rate of diffusion and water loss can be reduced. So this is a general review regarding this topic. Thank you.
What do you mean by water diffusion?
Actually, if we can say now, if the water will be depletion, but the water, already water is available in this well or maybe some place, so the water will be evaporated. So that's called the diffusion.
Okay, you just want to say that the evaporation of the water.
Yeah, right.
Okay, water evaporation.
Right. So that's called the diffusion. So it will be continuously.
The mechanisms are
Okay.
quite different.
Okay.
So water diffusion means okay, fine. Because for evaporation you need some
Right.
force, just like as a heat tank.
Right,
For
right.
diffusion you need concentration gradient or something like that.
Right.
So I was got a little bit confused. Can you just show me the title?
Yes. Discovering extinct water bodies in Gwalior Ward Zone, Madhya Pradesh, landscape coupled with diffusion, water loss
How
and
many
loss.
bodies you have discovered there?
Sir, actually, in our place, there are a lot of step wells is there. Some of the step wells are already working as a drinking water. But in the local areas, they are using.
Through the well, I think now we will use the different word, not diffusion, evaporation.
Evaporation.
Water
Evaporation. But some of the actually in the place historical Gwalior is a historical place. So there is some of the, we can say, step wells is there. Lot of step wells is there.
Because for evaporation,
Yes.
now here we are you confirmed that there is a evaporation, not
Right.
diffusion.
Right. Right.
So if evaporation is there, evaporation will be more when there will be more heat or more
Right.
surface area.
Right. So,
So wells
yes.
are already dig inside the what I can say in earth.
Yeah.
So
Right.
it has very less chance that the water will be get evaporated through that particular.
But due to the time being, so it will be destroyed
It's too
in
much
the
time.
too much time, because this is the like in the 7th to 17th century they are working. All the nearest people living that particular place, they are using that water. But in the current development, there are a lot of development is there, building or some other. So due to this, so we are depending to in the nearest like dam. There is a lot of dam is there in the near Gwalior. Like one of the Tigra dam is there, but they have already the lot of sources in the ancient time, but they are not use or recover that or reconstruct of that particular sources. So in the upcoming time, because there is no rain is there available, but sometimes we need, the peoples is growing continuously, we need a water. If we are dependent to other sources or in the nearest, if we are not our reconstruct or holding of our particular sources or revive our sources, so we are depending on other. So already we have sources, why we are not control of their what there are a lot of this government is working, some of the NGOs is working in this particular place. So we are just
And the next question is, first what I think that the wells are lost due to number of wars,
Right.
damaging the structure
Right,
of the
right.
wall, कहीं पे मिट्टी गिर गई,
Right, right.
कहीं पे कुछ हो गया.
Right.
Okay.
Yes, sir.
You can say that also in terms of rivers also. Okay.
Yes.
And to just minimize the water loss evaporation through the open bodies only.
Open bodies only,
You
or
can attempt the number of things. And the next question is, how did you determine the water loss rate? Means you have shown the graph now.
yes.
Yeah, so how you determine that
Actually,
water loss rate?
first in our work, so there is in the depth or in the raw material, we are just calculated in this particular place. But in our lab, so one I have some equipment regarding to there. Stephens vapor diffusion apparatus is there. So we are in one of the bucket is there. So we are using that calculation. So already we are getting from the different sources like municipal corporation. We are collecting the sources. That sources, water is how much depth is there in particular step well. So we are understanding what actually needs. So we are just piloting that things. Then we calculate by using this mechanism or by calculation of diffusivity, by calculating this already one of the mechanisms is there. So we calculating that things, then we understanding what actually problem is there. So they actually
the rate of diffusion of water itself without will be very low.
Very low. Sorry.
Rate of diffusion of
Yes,
water.
yes.
जैसा आपने
yes, very low.
प्रोटोटाइप बनाया होगा,
Right.
उसमें वाटर डाल दिया होगा,
Right.
और आप बस डिफ्यूजन का रेट निकाल रहे हो,
Rate.
कितना है, तो उसको तो बहुत टाइम
What time? But we understand the things ki already available that thing. If we are
just understand one question. Suppose वेल तो बहुत दूर की बात है.
right,
एक ऐसा ओपन पैन में अगर मैं पानी रख देता हूँ,
right,
और मैं रोज भी आके उसकी लेवल अगर चेक करता हूँ, तो भी वो बहुत ही कम डिप्लेट होंगी कि बहुत कम. So
Okay.
it's not a good method.
yes. But we are just saying, but we are main focusing on this particular stables. If we are
और step well में
do
उसके
something
लिए
for
difficult
this
रहेगा,
particular
because step well तो और जमीन के अंदर में रहेगी,
Right.
और वहां से उसका डिफ्यूजन होना, ऐसा हो सकता है कि वो वाटर जो था वॉल का वो कहीं और फैले.
हाँ, maybe sometime मतलब we are not only working only diffusion. Maybe अगर we are using to underwater filling.
Yeah. So
If there are some of the work on underfilling, so maybe it will be used after the water is refilling in our underwater is refilling. So it
Therefore,
will
it
be
will be a good title to discovering the various ways that why the water bodies are extinct in the Gwalior. It will be better, and there will be number of things, some
Yes.
ponds and something like that.
yes, sir.
Okay, fine, sir. This is your PhD topic.
No. My PhD on reactive. This is actually a student just working in there, or I am also involving. So I'm just collecting the data and then working. But my reactive extraction is my PhD topic.
Reactive extraction.
Reactive
Why
extraction.
sir is doing work on-
Yeah. By Kanti sir. Yeah. Actually, this is more water is lost. मतलब unit in a meter. मतलब maybe the depth is there. So how much meter depth is there and how much water is available. So that is
You
the
perform in lab scale, right?
lab skill or understanding मतलब और comparative study in by stables.
So, this was the last presentation of technical session 2. Now, I request Dr. Kanti Kumar Rathankar sir to felicitate our session chair, Dr. A. Vahid Deshmukh sir, with a memento as a token of gratitude.